Hey there, welcome back. Okay, this will be a relatively short lecture, and so I want to bring to your attention an invaluable aid for your success in organic chemistry. And I'm not telling you anything you probably don't already know. I'm positive your professor has already mentioned this, but I just want to hammer it home. And what is this wonderful aid? Well, let me hold it up. There we go. That's right. It's these little molecule tinker toys. It's a molecular model kit. And so there are many different flavors of these molecular model kits. Goodness, there must be at least 100 different versions sold by different manufacturers. But in every case, it's the same idea. You have color-coded atoms, the black are carbon, the white are hydrogen, the red are oxygen, so on and so forth. Here's another molecule that I made. The blue is nitrogen, the green is halogen of some sort. And you can even see that there are bonds. You can see there are bonds in between the atoms. Basically, these are Lewis structures, okay? But they're Lewis structures you can hold in your hand. Now, why are these so important and so useful? Because organic molecules are three-dimensional. We function, well, biological systems work on a three-dimensional basis, right? The molecules get recognized by receptors on the basis of their shape. Unfortunately, we live in a two-dimensional world in terms of being able to represent these things on whiteboards or notebooks, and so that's why these things are so handy. You need to work with these models. As much as you can. And so you must get yourself a molecular model kit. I'm just going to hold up the one that I use and that I like. It's the Prentice Hall kit. Your professor will recommend this one or some other kit. Your bookstore will carry whatever kit your professor likes. But either way, you know, it's a very good investment of maybe $40 or $30 compared to your textbooks. It's actually a good deal, and I'm telling you, you need to do it because we can't see in three dimensions. Well, let me explain that. We draw molecules on a piece of paper, and that's a two-dimensional surface. They're three-dimensional. They're actually three-dimensional objects. We have different tricks of representing the three-dimensionality on a two-dimensional surface, including what are called stereo bonds. You may know what this is. Okay, but still, it's nowhere near as good as this. The idea is that you work with these models enough so that your brain can then make the transition between seeing a structure, flat structure on a piece of paper, knowing that it really doesn't look like that. It really looks like this. So that's the idea. You want to develop that facility. Get yourself a set of molecular models or share some molecular models, okay, with your study group partners. We talk about study groups, I believe, later in the course, or I think I may have mentioned them already. I think you know what study groups are, but that's just a way to reduce your cost. But either way, you need to get yourself a set of molecular models and work with them. Let me say one more thing before we leave this topic. Okay, there's a computerized version of these same things, these molecular models. In other words, with today's tremendous computer hardware and software, people have written programs to simulate three-dimensional molecules on a two-dimensional computer screen. And your college may have such programs. I'll mention one that I really like. It's called Spartan Student. Spartan Student is a tremendous program, and I really can demonstrate it here for you. Maybe I'll post something for you so you can actually see what this is as a supplemental material. But it's basically this, but on a computer. And however, because it is computerized, you can do many more things with the computerized version than you can with the physical model. However, I'll still tell you there's no substitute for holding something like this in your hand. It's kind of like the e-books versus a real book, but more so. Okay, so if your college has your library perhaps has some of these programs loaded on the computers, the campus computers. You might play around with them. They're fun. They're informative. And again, like I said, you can do many more things with that than you can with a physical model. But you need the physical models. They're cheap. They're simple. Okay, you may or may not have access to the programs that are much more complicated. Okay, so this has simplicity going for it. And actually, I'll say one more thing about this, and then I'll stop. Ideally, you want to work with both. They're complementary. You ideally want to have access to a physical molecular model and to some kind of computerized program. Okay.